Hello again, and welcome to the next video in media computation. Let's go quickly here. Oh, let's see. Sorry, got to change focus. There we are. So before we can actually do more with pictures, I want to go back over some of the issues having to do with writing methods inside classes and how to handle loops and things like that. So this video is mostly about Java rather than pictures, although we'll do some pictures at the end. So as I've said before, in order to write a complete program, Java insists that there be a main class somewhere. You can have multiple classes, but at least one of them has to have a method called main in it. And the signature for main is public static void main, and then it takes an array of strings as arguments. We don't usually use that array as input to main. It's useful if you're going to execute a program from the command line, but we're going to pretty much ignore it. And we're also pretty much going to ignore everything else in main, just memorize the signature. To go back about loops, and this is more like pretest loops than just for loops. But for loops themselves are also called counted or definite loops because you usually have a fixed number of iterations that you go through the loop. And as we've seen several times before, the syntax of a for loop is the reserved word for with inside parentheses the initializer, the test, and the increment, and those three things separated by semicolons. And then inside a block usually is the loop body, although we've seen that the loop body can be a single statement, and then when that is true you can just not have to use the curly braces. Now remember how for loops and all kinds of pretest loops really work. There is an initializer at the top, which is what we have here. And oops, got to go back. Can't use the mouse. Okay. There's an initializer at the top right here. Then we have the test at the very top of the loop. And remember, if the test fails at the very beginning of the loop, you don't execute anything else. You just end up right down here. But if the test passes, you then execute the loop body, and then typically at the very end you change the value of the loop control variable so that you can make progress through the loop, and then you go back and do the whole thing over again. And then when the loop is done, when the test fails, you end up down here. Okay. Methods. We've written a few Java methods now just to refresh your memory yet again. Java methods have signatures, and the signature for a Java method has 5 different parts to it. It has modifiers at the beginning. Public is a modifier, static is a modifier. We'll see a number of other modifiers as we go along. All methods have to have a return type in Java. Most of the methods we have used so far have a return type of void, but we'll see at the end here when we do some examples that we can have other different return types. All methods have to have a name. The convention in Java is that method names begin with a lowercase letter, and then you use camel case to add other words to the name if you want to make the method that long. And then the last part of the signature for a Java method is the parameter list, which has to be inside parentheses. And if the parameter list is empty, then there's nothing inside the parentheses, but the parentheses still have to be there. And the parameter list is a comma-separated list of the input parameters to the method. Okay. Then the rest of the method, of course, is the method body, which has to be inside curly braces. There's no option here. You have, for a method, you have to use the open and close curly braces. Java is pretty agnostic about white space, so you could put the curly braces here at the end of the line, you could put the curly brace here at the beginning of a line, or whatever. The style I prefer myself when I'm writing code is to put the curly brace here at the end and then line up the closing curly brace with the left-hand side of the method's signature, which is usually the modifier. Okay. So, parameters versus arguments. In the method's signature, the list of the input variables are known as the input parameters for the method. These variables are local to the method and they are invisible outside it. What happens is when you call the method, these variables come into existence when the method begins to execute, and then when the method exits, those variables disappear. We'll come back to that later too. Then the second part is arguments, which is used when you call the method. So when you call the method, you give it a list of arguments and whose values the method will copy into the parameter variables and use during its execution. So you actually, if I pass a double to a method, the method actually gets a copy of that value. It does not get the real value. And this is called pass by value as opposed to something else called pass by reference. Most programming languages these days use pass by value because it's sort of more consistent and it makes more sense. So here's an example of a method signature. These are the two modifiers, public and static. Public says that this is visible. It's part of the API of the class. Static says that this method is visible in all instances of the class. We'll come back to that later. Int says that this method is going to return an integer after it executes. And then here's the name, find max. This is an example of camel case with the second word having its initial letter be uppercase. And then here are the two input parameters, int x and int y. Then, so this is what we use when we define this method. Then when we execute the method, we would create a couple of variables, and then we will say find max 12, 12 and y. 12 and y are the arguments to the method call, and answer is the result. So this method returns a result of that type, and so the type of answer matches the return type of the method. We'll do quite a bit of these. Return types can be any one of the primitive types, but they can also be classes, class definitions. So you can actually create an instance of a class and return that instance from a method. And we'll see how that can happen later. So you can also remember, and I've had a couple of questions about this as we started doing Java stuff, that you can put many, many methods inside a single class definition. And so, in fact, all of the operators that should be useful for objects of that class should go in the class definition. Scope. So, there are three types of variables in Java. There are what are known as class variables. They're also sometimes called static fields or static variables. There are instance variables. They are also sometimes called just fields. And then there are local variables. And the scope of a variable is the part of the program in which the variable is visible to the user, or alternatively, it's the part of the program in which the variable is defined, in which you can use it. So let's do a little bit more about scope. So class variables are visible in the entire class and across all instances of the class if they're declared to be public. They're always visible in the entire class, but if you want them visible from outside the class, then they have to be declared public. And class variables are always created using the modifier static, and they are always prefaced with the class name, as in math.py or bankaccount.nextNum. So if you were going to create a whole series of bank accounts, you could create a static variable called nextNum, and it increments every time you create a new instance, and you get a different number for each bank account. Instance variables are variables that are specific to a particular object. So their values are the values that only apply to that object, and they're visible within the object, and they're generally invisible outside the object because we use the modifier private to make them invisible. And so, for example, in your bank account, your name, your address, the amount of money you have in the account, those would all be instance variables because they're specific to that particular bank account, that particular object, and you want them to be invisible from the outside. You typically never want instance variables to be visible from the outside. So they're almost always declared to be private. Private's also a reserved word in Java. And the way you preface, the way you talk about an object, an instance variable in an object, is you preface it with the object name, as in ted.position or pict.size or something like that. So we'll have plenty of opportunities to look at instance variables and class variables as we go. Then probably the most common variables in Java programs are local variables. And local variables are only visible inside the method or the block in which they are declared. Instance variables can be hidden if you declare a local variable of the same name. But you can't do that with local variables. You can't hide them. Method parameters are local variables. Anything you declare inside a method is local to that method and is invisible outside the method, and there's no way you can make it visible. And then you can declare local variables inside any block. So anywhere you have open and close curly braces, you can declare variables inside that block. Those variables are only visible inside that block. They come into existence when you enter the block, and as soon as you exit the block, they disappear. Okay. Examples. So now I told you this would be kind of short, so let's go over here. And this is a project that I've created. Now here's a class that I put together to illustrate something. So all this does is it computes means in a couple of ways. And so you notice the modifier is public, so it's a public class. Here's the name of the class. Remember, the convention for classes are they begin with capital letters. Open curly brace to start the class. If we go down here, actually let's see if I can make this a little bit bigger. There. To get the entire class, and if I click down here in BlueJ, you can see that this open curly brace is highlighted, so BlueJ knows that this is the brace that matches the closing brace here. Here's an example of an instance variable. I can also actually, to be more specific, what I should do is I should say private double average for. And because that specifically makes that variable invisible from the outside. You couldn't use it from anywhere else. We're actually not going to use this one. I just wanted an example of declaring an instance variable for you. Typically, you'll declare your instance variables at the beginning of your class definition. And so now we have a couple of methods that I've declared. This first method will just compute the arithmetic mean of two integers. And so public static are the modifiers for this. I want it to be static so that I can see it everywhere. It's going to return a variable of type double. The name of the method is mean, and it takes two input parameters. Both of them are integers, x and y. I declare a variable called average. Notice this variable has the same name as that variable. This is an instance variable. This is a local variable. Whoops. This is a local variable. This local variable is hiding the instance variable. So once I declare this local variable, anytime I use average, it's going to refer to this variable and not to this one. That's what I mean by hiding. And so I'm going to compute the arithmetic mean just by taking x plus y and dividing by 2. I want the return to be a double, so I have to force the division to be a double by using a constant of 2.0. And then this is how you return the answer from a method. You use the reserved word return, and then you just tell it what you want to return. In this case, we're going to return the average. Okay. We do another example here, which is going to return the geometric mean. If you never learned what the geometric mean is, it's just the nth root of the product of all of the values. And since I only have 2 values, it's going to be the square root. And so this method is exactly the same. Here's the modifiers, public and static. It's going to return a double. Here's the name of the method. And it's going to take 2 arguments, both of which are doubles. It will then compute. Notice that I've also overloaded the word mean here. You can do that in Java because this is a local variable. And so it's going to actually hide that method name. And so this is going to be the geometric mean of 2 numbers is the square root of their product. And then once again I can return the mean. Notice that the type of mean, this mean is double, and I'm supposed to return a double, so that matches. If it didn't match, Java would whine at you. And then finally I have my main method, so I can actually call these 2 methods and do stuff. So I create a couple of variables here, and then I do system.out.println, the mean of blah and blah is, and I can actually call the mean method right here inside the print line argument list. Notice that I can spread the print line stuff across 2 lines. I could spread it across many, many lines. This is another example of Java mostly not caring about white space. And then to illustrate the other method, I create a double, and I call the gmean with that and double. I could also, by the way, just put this as 45. This is an int, and this method is expecting a double, and so all it will do is promote the double. So if I compile that again, you notice it doesn't give me an error because it understands that it can promote this int to a double when I make the method call. And so then if I go out here and if I execute the main method, I get the mean of 24 and 39 is 31.5, and the geometric mean is 35 point blah 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 blah. And that's actually pretty much it for this video. Come back soon. The next video really will talk about media. And thanks for watching.